source would magnetically focus, since remember the last lecture I gave, we spoke of the magnetic field as being potential field 90 degrees away from us. You have to have a special white noise source which is magnetically focused. Is a T sub infinity reference. So now this is Tesla's whirligig, as I call it. This is white noise. What is Tesla's whirligig? This is what we call our zero-time generator. If you remember, any of us familiar with the history of Nikola Tesla, he worked with all sorts of resonance, or as another friend of mine says, resonance. What he discovered is if you get two inertial rotating masses, inertially rotating, if you can relate the mass of the two objects, where the mass times the rotation of one is an integer relation to the mass times the rotation of the other. They're going to sync together through gravity. So what he built was a motor generator where the speed of the motor times the inertia of all the rotors in the motor generator was inertially matched to the rotation of the Earth. This was developed for the FAA in the 20s because back in the early 20s, the FAA was developing landing systems. They had to have a reference that was constant all over the Earth. They didn't have good crystals in those days. LC oscillators drifted like an SOB, as we still have today. So he decided to make this weird motor generator locked up onto the rotation of the Earth. Figuring the Earth is rotating the same everywhere, you'll have the same frequency everywhere. I have a number of these devices. Al has one in his possession also. They were built for the FAA in the 60s and the 50s. You turn the thing on, you hear the thing speed up, it whirls its way up, and then you hear it lock in. It doesn't lock into the power line. Why? It's a synchronous motor that they drive it with. 1800 RPM, which is a 4-pole motor on 60 hertz, or 30 hertz rotation. Now, I've taken that reference generator and operated that thing from 58 to 62 hertz. Its output frequency did not change once it locked in. Now, when you went below 58 hertz, 57 something, it dropped out of lock, and then the motor tracked the frequency, and when you went above 62 something to 63, same thing happened. So this generator is locking in to something besides the power line frequency, or else you wouldn't have that window where it doesn't change its frequency, the output frequency. Now, this locks to the rotation of the Earth. The Earth is now inertially locked to the rotation around the Sun. The orbit of the Earth is inertially locked through the inertia of the Sun and the Earth to the rotation of the Sun. The rotation of the Sun is inertially locked to the rotation of our galaxy, around the center of our galaxy. The center of our galaxy is inertially locked to the rotation of our reality. Now, people, what is the center of our reality inertially rotated, inertially locked to? Yeah, zero time. So this Tesla whirligig is a zero-time reference. We have our white noise, which is a T sub infinity, an infinity time reference. Now, what do we do with gravity here? What do we get if we do a cross product of these? Does anyone know? I know, it's difficult. Yes. Now, what is cross? A nonlinear function, a mixer. If we had about 16 hours, I could explain the math behind it.
You're just talking about
Two tangent functions, 0 and infinity, 90 degrees. Gravity is the crossing of no activity with all activity. You create a rotating vortex wind between the 2 points. Remember, we just said that 0 time is t sub 0. Time infinity is a tangent of 90, tangent of 0. We got the tangent of 0 here. We got the tangent of 90 here in the white noise. Now we got to take this one off. Well, I'm going to leave the antenna in delta t. Now I'm going to show you how to make this device. Although this is a lot bigger than the device we've made. We'll get into how we make that device later. I'm telling you at this point, I'm showing you the secret of time. Time modulation. Okay, let's put over here our 0 time reference. This has 2 outputs, 30 hertz, fixed, and 30 hertz, phase variable. If you look at the Tesla 0 time reference, it's got a big knob on the front and a dial behind the window that says 0 to 360 degrees. There's 2 30 hertz alternators. One is rotated by this knob and dial. So you can gain precise control by rotating the 2 generators to each other, which relates to the Eldridge out. Because they're now changing the rotation by changing the fields. In this case, they rotate the entire field mechanically. So it's got 2 outputs, 30 hertz, reference phase, and variable phase. We take these 2 outputs, we put them into mixers. Now, we take our white noise generator, our general radio. I think it's an 1863, if I recall, which is a little box about that big that has a Gaussian noise tube in it and 2 6AQ5 amplifiers with its levels and a level control meter for its output, has bandwidth limitations. This thing can go to 500 kilohertz bandwidth or 20 kilohertz, or I think it's 5 megahertz also. I remember it's an 1863. Get the old GR catalog and look up their Gaussian noise source. This thing, general radio, this thing is available on the surplus market, a dime a dozen. General radio must have made trillions of these things. You modulate with the white noise output. Well, also you have another tap. Now, what do we do next? The function you're going to put into the delta time has to be a quadrature function. Another mixer. 2 mixers. This is going to be f sub x, and this is going to be f sub y. This is the dual output from the Montauk chair system. They're a quadrature, 2 outputs are right angles to each other. Then we go here, the 2 amplifiers. This one becomes the Y amplifier for the Y loop. This one becomes the X amplifier for the X loop, here and here. So what are we doing here? We are taking our cross product function that you're using to generate the frequency transform you want to broadcast, putting it in here, driving it to the 2 sets of coils, X and Y. This is going to create your twister, a rotating, very small donut where the diameter of the donut essentially is 0. if your bandwidth is infinity. So it becomes 1 over the bandwidth. Now, what do we do with Z? It's very simple. Another amplifier to Z. This takes our twister and makes it into a spinner around the antenna. Now, by crossing the two functions, you can now remember, I was talking of taking delta functions of a particular bandwidth. Because you're crossing the two delta functions with 90-degree loops, this will be like multiplying the two tangents together. And this will give us, operation-wise, an infinite bandwidth outside the antenna. You'll get an infinite bandwidth. What are we generating here? A vortex. Because of the fact that this rotating vortex is built up of a frequency transform function, which by the activity of the right angles of the antenna, 3 right angles now, it's all going to appear to be noise, because we're modulating our signal with a noise gated by the 30 hertz. They are coming from a computer, a mine amplifier. This is your function that you're broadcasting into the time domain. I'm telling you, specify it's got to be 2 functions in quadrature to each other. It's got to be biphase quadrature, which, to our medical people in the audience, what organ in our body works on biphase quadrature? The brain. Somebody, who was the bright man that said the brain? Stand up, sir. A round of applause. We got somebody that's awake in the audience. I've just shown you. Now, you can fine-tune the phase relationship from the zero-time reference. What you'll find as you tune through, you'll be able to actually fine-tune how far in time relationship this will vary. If you match the 90 degrees here to the 90 degrees here, if the fidelity of all the information channels is infinite, what do we have? We have a controlled time portal in the center of this antenna. Now, we've left one piece out. How do we construct our delta loop? Let's take one loop. Do we have any old radio men in the audience? What's the next thing we do with this, sir?
Well, that looks like a rhombic and start.
You shield it, right? We're making a magnetic probe here. So you put a shield around this thing. What do we now got? A radio direction finding delta loop. But what's going on here? We're taking E cross B and stripping the E off it. What do we have, folks? We have a function which is already ortho-rotated 90 degrees out of our reality. Now, how do we control this? We put right down the center of this thing an antenna, a rod. At the same time, we have our ground function. We connect the rod and the ground to a switch, a commutating switch. I gotta make this dotted. We drive the switch from the rotation of the zero-time generator. It's got to be integer related to the rotation of the wheels in the zero-time generator. What do we hook here? We hook our radio transmitter. Now, this is a very unique radio transmitter. It's ISB. Any of the hams know what that means? Independent sideband. This is a double sideband suppressed carrier transmitter. But lower sideband is at 0 degrees. Let's put it over here. Is at 0 degrees. Carrier equals 90 degrees. Upper sideband, upper is 180. This is called a bi-quad, bi-phase radio transmitter. We put into the upper sideband F of Y. We put into the lower sideband F of X. Now, at the same time, we take this transmitter and somewhere in the amplifier chain, we put a gate or a mixer, and we put our white noise. We take the output of the transmitter, put it into this RF switch. How many people have seen the electrogravitational generator, which is a torus coil with another coil inside of it, where they put a high voltage potential between it? This is what we have here. We put this between ground and our RF signal back and forth. From the Eldridge, the 4 coils created the delta T magnetics. The RF transmitter created the electric field component of this. Now, when you do del cross B, del cross E, del cross G, sum it all to 0, it equals 0, all imaginary. That becomes your time modulation. Now, your lecturer is going to have to take about a 2-minute break. I got to go to the facility. I have to. When we come back, we're going to talk about the transistor and the special device that Al was talking of. Anyone know what a tunnel diode is? All right, we got one bright individual. How do you make a surface barrier tunnel diode? You take a piece of semiconductor material, silicon, germanium, gallium arsenide, it doesn't matter. Let's say it's P. No, let's say it's N. N is easy to make in the old days. You deposit, you take this and you etch it so it's absolutely flat, electrochemical etch, which means you take a jet and you put out a chemical, and then you take that conductive jet and you put a voltage source between it. And you etch, electrochemically etch, you use a chemical which is a salt of the semiconductor, and you electrically chemically etch an absolutely flat face that is molecularly flat on the surface of the germanium crystal. Then you shut that off. Then you put on top of that a metallic contact. Now, because of the electron pressure coming up here, hitting the barrier coming back, it builds a depletion region without putting any polarization across it. It builds a depletion region. Notice this thing with nothing has a depletion region. Now, if you put a current through this, what's it going to do? It's going to build up electrons on one side or the other side of the barrier. When you reach a particular point, they're going to punch through the barrier. But it's not a punch through, they tunnel. Remember, we built up a potential spatial charge, and as long as you don't exceed the charge across the barrier that the spatial charge represents, your current now is tunneling. It's not going through, punching through like a transistor does, where you combine the holes and the electrons. I don't expect this to be clear to everybody. This is essentially for technicians and engineers at this point. The people who understand, you're following at this point. Now, what's the characteristics of the tunnel diode? I versus voltage. It goes up, then it comes down, and it goes up again. This is your tunneling region here. What this is saying, as you increase the voltage, the current goes down, not up. That's your negative resistance. Any negative resistance device you can use as an amplifier. Now, let's go into what's actually happening in this depletion region. I'm going to take this point here and expand it. This is your indium contact. Here over is your germanium. This is the depletion zone. This is the germanium. This is the indium. Now, as you bring a potential this way, remember, Al was speaking of a rotating vector on the edge of a time. This is going to create a rotating vector on the edge of electron flow. You follow so far? This is the spinner and twister creating around the tunneling electron. What is this twister, spinner? It's a vortex. It's a vortex, folks. What is a vortex? A hole in our space-time continuum. Now, what happens if we put a Dirac delta pulse in this current flow? The vortex will instantly turn on, the vortex will instantly turn off. What has all the mathematics that we've gone through say when we take a vortex generation, turn it on, turn it off? You do a frequency to time transform. So the faster, the narrower you pulse this thing on and off, this now becomes a miniature time vortex, which means when it goes from this end to this end, it becomes electric current here. It's electric current plus a time current. So we got E here. Here we got E plus delta T. What we just learned? A tunnel diode is a delta T diode. Does the engineers and technicians follow so far? Now, let's go another step further. As I erase, I'm going to talk. In 1952, the aliens contacted President Eisenhower and said, hey, we want to get together and talk with you. We all heard about our treaty with the aliens. One of the things they asked us to do is, we got this problem, we got a reliability problem of a very strange semiconductor device similar to your transistor that we use on our craft. We want to have you and Earth be this sector of our galaxy source for these devices. We'll show you how to build them. What did they show us how to build? No? Surface barrier transistors. The tunnel diode came out of the surface barrier transistor research. According to a friend of mine, let's call him Clark in the book, he worked for a company called the Electronic Transistor Company. In 1946, 1947, Osborne, Shockley, that crowd working for Western Electric had formed, at that point, in the 50s, Western Electric split up. The semiconductor manufacturing part of it split off, and it was essentially owned and run by Osborne, Shockley, et cetera, et cetera, et cetera. What did they call this company? The real name is the ET company. They knew all along that the transistor developed by Bell Labs in the mid-40s was from the initial contact with the K group in the 30s. That was the first technology exchange. They gave us the crystal amplifier that we call the transistor. Now, they were hoping that at some point in the 50s, the ET involvement would be announced to the public, and they could capitalize on that their company is developing technology given us to us by the ETs. ET company. Now, they were not at the point when they formed this. They weren't going to call it the extraterrestrial company. They had to come up with a name for the crystal amplifier. E, of course, is electronic. Company, of course, is company. They went through name after name after name for this device. They came up with one name, transistor, that had a T. So it became the electronic transistor company. This was the R&D production facility. It used to be Western Electric. In other words, Philco, Sprague, RCA, General Electric, in those days did not have their own facilities. They bought all their devices from the electronic transistor company. Of course, in the mid-60s, the electronic transistor company became a public corporation. They put out a catalog about that thick. You could buy any old transistor you wanted from, even the discontinued ones. Now, the Philco Research Laboratory in Philadelphia, Pennsylvania, was run by Philco, the electronic transistor company, and U.S. Navy. Clark tells a story that there was a man by the name, he called him Onopole, the man's real name is Annapolis, who was an officer in the ET company. Clark used to work for Annapolis when he was going to RCA institutes. He tells this story that Mr. Annapolis, or as he put it, Onopole, would come in and told him, you know where these crazy little transistors you were working from came from? Clark says, oh no, I don't know. He said, well, he was assigned at that point to the Navy Philco Research Laboratory in Philadelphia. Now remember, we're talking 60s. This goes back to 1953. And that they took a back end of the plant that had the research facility, cordoned it off entirely, put all sorts of high security in there. They developed the surface barrier transistor in there, and this fellow told Clark that every day these tall characters would come in black trench coats, black hats, and like a mask over their faces. When they got in the back, they took the trench coat off, the mask, and the hat, and they were literally 7-foot-tall gray aliens. Clark said that Annapolis described the gray alien perfectly, and that the gray aliens were telling us how to build these transistors and helping us develop the manufacturing process. And this was surface barrier transistors. I think in a little bit Al can talk about what he psychically picked up they were doing with these transistors, but either way, let's now go in and consider, what is this transistor? We take our P-type material. P-type material is what, Mr. Engineer? A whole electron source. This is germanium semiconductor that is doped with an ion, which has excess electrons, so it's a source of electrons. I'm not going to go any deeper into semiconductor theory. Now, instead of having one electrochemical etch jet, you put two. And you have two batteries here. I don't know if the polarity of the batteries are correct. I don't care. And we smooth out two sides of the crystal. Yeah. It goes like this. I see somebody remembers the surface battery electrochemical etching process. Stand up, sir. Let's have applause for him. Now, once they do this, what do they end up with? Let's look at this little tiny piece here. I am the consultant today, the engineering and production consultant for the ET company, by the way. This is where I got all this information from. Now, you take one, you deposit the indium material on the etched surface. Now, you may put some other crud on here and call it MADT, call it MAT, call it SBAT. You know, the surface barrier transistor was owned by the government, and the ET company tried to capitalize on it, change the design a little, and what they would do is they would change the emitter junction. Now, what you have to consider is this. The spec sheets say that it resembles a PNP transistor. What's going to happen here? When you change the bias on the zone that is outside of the, what the hell they call, electron pressure generated depletion zone, you're going to move this. You're going to create vortexes. Tunnels. We now have taken our tunnel diode and made a tunnel transistor. Now, what's going to happen here if we make a common emitter amplifier, ground this, I'm going to make it dotted because we're talking of AC ground. We put our pulse here, and we put our load here. We're going to control the tunneling between the emitter and the base, and the base and the collector. What's going to happen is the delta T current based upon this pulse is going to circulate this way, which means now we're going to take our input signal and convert it to an electrical signal plus a delta T. This is your delta T amplifier. What do we do with this thing? Take this thing, connect it to, as Al was saying, a 555. Put a current limiting resistor so we don't blow the hell out of the base. You can't get them. No. I lucked out because after the boss man gave me a pile of them, and then maneuvered me to give the pile back because he was told by the government, no, you can't do that. I remember seeing in the Allied radio catalog MADT transistors. So I got an old catalog, looked at it, opened up the page, sure enough, there it was. So who is Allied Radio today? Radio Shack. So what I did, I called Tandy in Fort Worth and said, hey, I'm interested in a product that you guys used to sell in the late 60s. I gave them the part number. They went into the computer. Oh, yeah, we got those, sir. We got 40,000 of them. So I say, well, how come we don't have them in the catalog? Nobody wants them anymore. We still got them in the warehouse. We don't throw anything away. So I say, well, send me some samples. So they send me about a dozen samples. Yeah, these things are surface barrier transistors. So I call them up, and I make a deal, and I buy all 40,000 of them. And I said to them, anyone else in the country you know of have any others? So I've called a few other small dealers, you know, associated dealers, allied dealers, and I got about another 1,000 on top of that. At this point, just as I did with radiosondes when I built the biosonde, I cornered the market on surface barrier transistors. If you go to ET company today and order them, although they got them, they're going to tell you they don't got them because there's legalities involved since the company was told in the 70s to destroy them all. They're not going to admit to anyone outside of the group, which I'm part of, that they have these transistors. So, where do you get surface barrier transistors? From Preston, right. This is how the delta T transistor works, and I'll give it back to Al now. Because what I did is 6 or 9 months ago, I handed out one of these little blue boxes I prototyped. Oh yeah, I forgot to describe the coil. What we're using is a coil with 4 pi windings, spider wound. Difference is, the bottom one is spaced further away. Just as Tesla noted, you could direct the direction of the flux by changing the spacing. So we got a coil with 3 closely spaced windings and a distant space winding, and the time flux goes this way through the coil. Well, somebody had to ask that. It's really complex. I know Al may want to refer to this, right? So I'm not going to erase this. You take your coil form. You rotate it. You take your feed, and it goes up and down each time it rotates. What you get is you build up a winding a little at a time, and you do 4 of these. Each one is called a pi winding. It's called pi because it goes from 0 to 360 degrees each time the form rotates once. And you just keep taking about number 60 wire, and you build it up. The whole impedance of this thing is about 1,000 ohms. The current through the transistor is maybe about 10 milliamps. The whole thing draws about 15 milliamps from a 9-volt transistor radio battery. And from that point, I'm going to give it back to our distinguished Eldridge survivor, Mr. Edward Cameron. Come on, Mr. Edward Cameron. As I said, I gave him one of...
I'll dig in my little goodie box here. And that's just where I put it. Here it is. And I'll come out with a delta T generator. It's not a very big device. You can actually stick it in a coat pocket. The entire circuit, the coil, the battery, everything is in here. If you want to take a picture, you're welcome. And it has a little LED in the back to let you know that it's on. A huge filter capacitor to smooth out the current. I didn't show every detail of the circuit. It's not really necessary. But now you got a very interesting function on this. If I remember correctly, Preston, the surface with the 4 screws is the output side, right? Right. And if you turn it to where the little legs for this box are, it's a standard ordinary Radio Shack or whatever plastic box. That's the vacuum cleaner side. And I also have here a little adjustment pot there in order to change the frequency. Right. Right. And the coil sits in here. Literally. All right, I have a little screwdriver in the case I think I can use. But in any case, I don't know how many of you people are sensitive, but we're going to find out. Turn this thing on. It's now on with a little red light. See how many people feel anything. Anything at all. It's on. You know, those who are scientists and engineers usually are not too sensitive to subtle effects, we'll put it that way. Little red light says it's on. And some people have noticed if I turn it edgewise, I get a terrible headache. Not trying to suggest anything, but I want to see whether anybody feels anything in here. Okay, now if you turn it this way, it acts like a vacuum cleaner, a very strange vacuum cleaner. It doesn't suck dirt, doesn't suck air. It will react in a metaphysical manner. I have played with this thing now for some 6 months, more than 6 months, perhaps 8. And I found the frequency setting is fairly critical for some people. But if you have a problem with how shall I put it, an energy implant, not the solid crystal type which the aliens and or the government use, but an energy type implant, this device will pull it off the body. If you have problems with, well, you could almost say ET attacks. If you have problems with entities of any type which are attacking you, this thing will usually end the problem. They don't like it. I've used it more than once for that purpose, including up in North Carolina recently, where we had an infestation of ETs at a certain symposium, which Preston and I and Duncan were at. They didn't like this thing at all. They left. They were not physically present in the sense of being you or I or anyone else in the physical, normal reality. They were present in an altered or a parallel reality. Now, this gets into a very interesting aspect, which I don't have time to cover fully, but very briefly. There is alternate realities. There are several of them. The government does have means to cross over into these other realities. There is a project called Project Winter Haven, which is developed parallel to the Montauk Project, probably under the cover of the Phoenix Project. And this is a project for interdimensional travel. And by using interdimensional travel techniques, some of these so-called spirits turn out to be quite real, because what is the spirit world but another reality? Quite physical to their own references. Your dream world is quite physical when you're in it. Therefore, one has to come up with a question: what is reality? We think we know what it is because we can hit a table. If you hit a car under a brick wall, you smash the car, you might smash yourself. If you could do an alternate reality shift quickly enough, you wouldn't hit the wall. Who knows what you'd hit in the other one? But this gets into a very strange and difficult area to analyze. What is reality? We accept ours as real because we've been educated to it. We feel it. We know it every day. But there are other realities, and other people there that know their reality as real. They probably look at us as ghosts, if you will. But there is occasionally crossover under certain conditions, dimensional changes, dimensional doorways, which can be artificially created, or naturally they exist without artificial creation. But a device like this can prove useful in terms of if you got uninvited visitors that you don't like. Okay. We don't have it in production yet, and I can't really give a price. This is one experimental unit. Preston had built 1 or 2 others on a breadboard, which are about 5 times this, cover a 12 by 12 inch breadboard. But if we do get it in production, it's, I can put it this way, it'll be more than $100 and it'll be less than $1,000. The circuit is fairly simple, but we have to consider a number of aspects: frequency stability, adjustability, durability. We still don't really know how durable that transistor is. It's a low voltage device, as most germaniums were in the past. Typically, a germanium had a VCE rating of about 10 volts, 9 volts to 12 volts, 15 was high. This is a 9-volt transistor. These are hand-picked to handle about 25 volts. And that's one of the unknowns at this point, is how stable is that transistor against transients. You won't get much transients with a big filter cap on a battery. But it might if you're in an area where, let's say, there was a powerful radar transmitter or some other very powerful electromagnetic transmitting device. Anything from an FM transmitter to a TV transmitter. They'll put up a lot of voltage if you're too close. And if the circuit board happens to be critical in terms of the layout, the length of the leads, and you hit a quarter wavelength lead, you can build up a rather high voltage internally on a transistor because of the lead lengths on the board. Right, that's the other aspect. The coil is directly connected. Right. Okay, I'll see if I can find a screwdriver and take the lid off so you can see what it looks like. Because it's
What have you practically done with it?
practically, I've used it to end problems with people who had attacks of one kind or another. Energy attachments, one could call it, which is a form of implant, but is not a physical crystal type. Physical crystal types have to be removed surgically. Biological implants can be destroyed by electronic means. This is not powerful enough to do it. It can be used to stop a form of mind control where people are trying to impinge. Those are the capability of transmitting a form of mind control. And I'm talking about hardware. I'm talking about mind control from another person's mind who has the capability, impinge on a secondary party, bad energy, feeling bad, et cetera, et cetera, et cetera. One can do a number on those people which breaks it and gives a person back some peace. Then you have to look at the other aspect of who is this and why are they doing it. Yes?
Have you done any experiments with, like, time anomalies? Does it change the rate of time?
It changes the rate of time in a very localized area because the output is a cone of energy. And since time is one of those elements which is basic to the universe, it does not know a distance limitation, even with a small box like this. There is no 1 over d squared or 1 over d attenuation. There is no attenuation. Sorry? What does he?
Why is the area localized?
It is localized because of the size of the coil at this point on the edge of the box. It fans out as a cone. It fans out as a cone of energy. The further you go, the more it spreads. But it does not attenuate insofar as any tests I have made on it are concerned. I've had people that pick it up and sensitive to it 2,500 miles away from Phoenix to the East Coast. I'm sorry? Nope, haven't had any so far. There's not enough power. You would have to have a very large delta T function for that, and a considerable amount of power, more than a 9-volt transistor battery. Perhaps something which is charged by a 12-volt car battery might do it. Yes? It is basically a psychotronic type device, psychotronic effects, yes. And in that sense, the effect is not physical insofar as any affected tissue is concerned, so far as we've been determined at this point. We have not yet built a detector which can directly measure the output of this thing. We're working on that. And that's another aspect. If we say we got something coming out of here, we've got to be able to prove it. We can prove it directly by the subtle effects that some people pick up, but that is not hard proof. That's very soft proof. Oh. Right. If you have this thing properly modulated, it will affect the person that way. If you put a scramble signal on there, there's no telling what it can do to a person's mind if there was enough power. So the government knows how to manipulate these things. They use mind control devices all the time. Okay. Mm-hmm. Okay. Well, I had it on the vacuum cleaner side, which says it was pulling and then it stops pulling, and that's probably what you felt, the end of the pull. Now, not everybody can feel this device. I'm not. Anyone else that had a feeling for it? You did. Anyone else? Okay. It says that there was a low percentage here, but at least there were 3 or 4 who did feel it. 5. You have a question? Okay. Transmitting device, receiving communications. Very definite possibility, but one has to have a detector in order to demodulate, in order to use it as a useful transmission of intelligence device. You want to have two links, a transmitter and receiver. This is a transmitter only. And we do not have any modulating techniques on this. It is strictly a square wave generator driving it. Yes?
This is maybe a question more for the rest of Nichols, but why couldn't one use a field effect transistor, which has very narrow base region?
Well, field effect transistor does not help.
Yeah, that's a very special function.
The tunnel is what makes this work.
Yeah.
This is a tunnel transistor.
Just a comment. My experience with those type of devices, or those type of diodes and transistors, is that they're very sensitive, and if you place them in a properly machined cavity, you can get bandwidths up to 300 gigahertz.
Yeah, I don't.
And
Yeah.
rise time.
It's called gun diode.
Gun diodes, right. They seem to have disappeared from the market. There are many things you can do with the properly built germanium devices you cannot do with silicon. And this is a technology which has been almost forgotten and buried, but probably not in certain government circles. Anyway, you have another question? Okay.
Earlier in the presentation, you said you were going to mention what happened to the vessel that was sold to the Greek.
Yes, it's interesting you did bring that up. Some interesting feedback on that recently. The feedback has come back to us recently about the fact that it is still in the Greek Navy, and that over a period of years the Greeks have had a few strange things happen. They found a number of locked rooms which they could not get into until they forced locks. They had some closets or standard type ship's lockers. They finally forced one open and a skeleton fell out. And they found wiring all over the ship that goes nowheres. It's just sitting there unconnected, and tons of wiring apparently with no connections to anything, and they don't know what it is. Well, I think I do. All right, I think we all do by now. But that's some of the feedback on that. I've heard other wild stories about when they first had the ship, they were getting some very anomalous effects which caused them to almost strip the ship and repaint it completely before they felt the stuff would, whatever it was, die down and they could go out to sea with it. The stories are anecdotal, and I don't have any first-hand evidence or proof of it.
So I'm the same source and told that the U.S. government wants to buy the Eldridge planet.
Yeah, they want it for a museum piece. Ho, ho, ho. There'd probably be a cutting torch applied to bury it forever. That is also in the communications we have. The government would like to get it back. One other question? Okay. In the back.
It would appear to me that in 2023, that the Eldridge might disappear, regardless of whether you have machinery on it.
Well, there is no machinery on the Eldridge now other than a normal complement for a warship. Why do you pick 2023? Oh, 3, okay. It's an interesting thought. It didn't go into 83.
But, you know, when you went back to cut the wire, or cut the cable, you were at a particular angle between 0 and 90 to do that. So what is to say that the spin hasn't rotated slightly back into the
Yeah, that's an interesting thought in terms of alternate realities and repetitive cycles and all of that. We've explored that thought-wise, and we do have reason to believe that we've probably been through this circuit more than once, but that's something we don't go into now because we're not sure of it. That's an interesting thought. Thanks. Yes? No. No, almost all of that type of device has been withdrawn from the market. Very nice little neat widgets. And the gun diode disappeared for about the same reason. Today you have a restricted market in terms of what electronic devices are available to the general lay public or the general experimenter. I haven't seen or heard of any, and I know somebody who's been trying to locate them. Maybe they're surplus. Whatever. Okay. Well, I think that's about the end of our talk here. I will get a screwdriver and take the lid off the box, but I will thank you very much for your attendance and your interest.